We'll proceed in vector and commercial calculus, vector and energy calculus, vector and commercial calculus. Long discussion, but I believe it is worth worth mentioning it. Vector and energy calculus. Vector, you are amazing, you are awesome because you are the only entity that makes any mathematical computation complete. Because of vector, we see direction in the computation. Otherwise, there is no direction, only a scalar value, numeric value, algebraic value we get without any direction. One person is running at 10 kilometer per hour. Okay, another person is running at 20 kilometer per hour. Okay, they both are running in the same ground. This the third thing I talked, they are running in the same ground. Now it is little bit about the position and direction. They started from the same location, one in I direction and one in J direction. Now same time they started. It is crystal clear now that what's going on. A person running at 10 kilometer per hour started from the same point another person is running at 20 kilometer per hour. Same time, same point. One in I direction, one is in J direction. One in I direction, another is in minus I direction. Another in minus J direction. One in I direction, one in I minus J direction. Okay, so vector makes everything complete. Anyway, we are into deep calculation of divergence. Divergence is something that is that deals with completely deals with energy. Divergence means computation of energy. Okay, so what we have seen till now as far as divergence is concerned. Divergence, first we calculate the flux. In mathematical computation, we calculate the flux. Once we calculate the flux, then we go for flux density and divergence. So I would reiterate the fundamental behind divergence. Okay, so fundamental behind the divergence. Okay, can I take a bigger cylinder? Okay, so I have a cylinder. Anyway, I was taking example of this cylinder. I have now this cylinder. Hup, hup, hup. Or actually, pens are there and it is leaking. Fully red. Okay, anyway. Hup, 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 hup. Okay, so divergence means consider full red here. So one pen is leaking inside it. Okay, anyway, so divergence means like as I give example, like I this is a cylinder and cylinder has this surface and this surface. Now consider this surface area and this surface area is same and there is a liquid that is entering this surface and exiting from this surface. If there is change in velocity of the liquid, liquid entering here at a speed 10 meter per second, 10 meter per second, and liquid that is coming out here is 10 meter per second. If this area is same, then flux is velocity vector dot product of the area vector. This has area vector in minus x axis. This has area vector in plus x axis. This is x axis, this is y axis, this is z axis. Now in that sense, now the flux, the net volume, meter per cube per second, meter cube per second is the net volume of the liquid that is passing through this surface inside this cylinder. And then it is coming out of this surface meter cube per second. If the liquid is entering here meter cube per second, it is entering here meter cube per second. Okay, it is entering 10 meter per second is the velocity. After multiplying with the area is 1 meter square. Area is 1 meter square. So liquid is entering here at 10 meter cube per second. The liquid is coming out here 10 meter cube per second. If the if it is 1 meter, if the velocity is 10 meter per second, here also 10 meter per second. What is the flux of this cylinder? And all around the surface, the area vector is like this. Area vector is perpendicular to the velocity of the liquid. Liquid will not come out from here at all. Okay, complete liquid will come out from here when it is entering here. So flux, that is the velocity into area, net liquid that is coming out of the surface along this is zero, because it will not come out from here because it is perpendicular. It will come out from here because liquid velocity direction and surface area direction is same. Here also liquid velocity is this and surface area is this only in negative direction. So dot product will work. Angle will be 180 degree. So 180 degree cos theta will be minus 1. So if I add this flux will be negative. This flux will be positive. Negative plus positive, 0. So no flux is happening here. This cylinder has flux and it is 0. Net flux is 0. Means here flux is there but negative because direction is this side. Here flux is there but it is positive. Direction is this there. Net flux is 0. Okay, what about flux density? Whatever is the flux, divide it by the volume of this cylinder, that is called flux density. Whatever is the flux, whatever is the net volume of the liquid coming out of a surface divided by the volume of the entity, that is flux density. So here the flux itself is 0, then flux density divided by volume of this cylinder is 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 0. Flux density is 0. What is the formula of flux density? Flux density is, if I take any volume, then what is the flux of that surface of that volume divided by the volume? Okay, that is called flux density. Or consider that I have a like a, okay, so I have one energy source kept here. There is an energy source and it is kept here. If energy source is kept here, because of energy source, there is I always give example. There is electric charge out here. Because of electric charge, electric field is coming out of it. Consider electromagnetic field is a liquid kind of thing. Electromagnetic field is a liquid kind of thing. Now I have something like I have one kind of okay, it's a big orange. So I have one shape kept here. Now electric field is entering this shape from all this direction. Here it cannot enter because here area vector is perpendicular to the electric field. Same is here. Otherwise all around it the electric field will enter and from this side electric field will exit. How much is the flux that is coming out of this surface? So this side surface area is like this, perpendicular to the surface. This side, the surface area is like this, perpendicular to the surface. Okay, if I consider this side as positive and this side is negative, this is how it is. So anyone would say probably your flux is 0 because whatever you see this side that is negative, it is kind of compensated by whatever you see this side positive. Okay, I don't know, it will be 0 or whatever, but whatever the liquid that is entering here and whatever is liquid that is coming out here, If entering and coming out is exactly same, then it is not it the flux is considered as zero. Flux is considered as zero. What is not zero then? What is not? Consider that flux, the liquid that is coming, the electromagnetic liquid that is entering here and that is coming out of here. When it is coming out of here, it is more in quantity than it is entering here. It's not possible. Consider it is possible. Consider it is possible. Or it is exactly kept like this, and exactly this is x axis, this is y axis, this is z axis. Exactly. An electric field is exactly along the x axis, then certainly whatever is entering, same thing will come out. But it is not coming out. Entering here, the flux amount, that is the velocity into area. Here area is not same, area vector is different. Velocity vector dot area vector. Whatever is entering through that and whatever exiting, entering, consider it is entering as 10 meter cube per second. That much is the volume entering through the surface. Coming out is 12 meter cube per second. What is the flux? Then flux will be 2 meter cube per second. This side, if I consider negative side, this is positive side, then 2 meter cube per second is the net flux. Divide it by the volume of this sphere or whatever it is. That is called flux density. Per unit volume, what is the flux? Per unit volume, I'm not talking about per unit surface area. Per unit volume, what is the flux density? Per unit volume, how much is the flux? Net flux divided by the volume. Per unit volume, what is the flux? That is called flux density. If flux entering here and flux exiting are different, then certainly there is a flux. How it is different? If this consider there is a flux called F and F is along x-axis. If F is along x-axis, then this is F. F vector. F is a velocity vector and it does not have any component along y-axis. It does not have any component along z-axis. In that sense, the F field is going along x-axis. Now, consider this side the surface area and this side the surface area are congruent. They are similar. In that fashion, if here the liquid is entering at x meter per second, then certainly liquid is exiting here at more than x meter per second. That's why x into surface area is 12 and here here x into surface area is 10, and whatever is coming out here into surface area that is same as this side is 12, means velocity is more. If velocity is more and the inside it is same that the way it is entering, this proves that there is a inside it or at the center of it there is an energy source. The way I am saying there is an energy source, because of energy source electromagnetic wave is entering and exiting at different speed, area is same, so net flux through which it is coming out is higher, so flux is there. If flux is there, then how come the coming out is more? The net amount of liquid that is coming out from here is more. Means inside this there is a energy source. Please mind it. I am talking about energy source. So there is some energy source inside it. If it is centered at the origin, if this is centered at the origin, then at the origin there is energy source, and that energy source is emanating liquid and it is adding to previous liquid. If more liquid are coming in the same region, it is enhancing the speed, and it is enhancing the speed, and then net throughput is more. So divergence is calculated not for, I'm sorry, flux density. So this has flux density because net flux is non-zero. Now divide it by the volume of this sphere. If you divide it by the volume of the sphere, then someone can get the flux density. Per unit volume, how much is the flux calculated? There is some other calculation is called divergence. Divergence in the sense, if flux is non-zero, flux is non-zero, it means that there is some uh, energy source that is available at the center of this. Divergence flux density is calculated for a point. If there is a flux velocity into area, divide it by the volume, then meter is going away. Flux is meter cube per second. Divide by the meter cube, meter is going away. Means the flux density is dimensionless. If it is dimensionless, then more or less we are talking about the flux. We are talking about the whatever the flux density, something that is at a particular point, which does not have any dimension at all. Okay, similarly, let's go more on it. Let's go with something called divergence. Divergence means there is a point inside it, there is a point inside it that is behaving like an energy source. And from there, the liquid is gushing out and then it is adding to the incoming liquid, and that's why velocity is growing. And then velocity that through which the liquid is coming out is more. Area is same as the incoming area and outgoing area. And this way, flux is positive. So divergence is calculated at a particular point. So if I have a point, make a volume around the point. Okay, it needs to be concentrated. If I have a small point, now around the point, create a volume around it. Consider point, there is a point, and point is kept at the origin. Now around the origin, make a sphere of radius r, where r is tends to 0. There is a point, there is energy source kept at the origin. Around the origin, create one sphere, 3D sphere, where the radius of the sphere is r, where r tends to 0. This means that the sphere is contracting. Okay, it's not expanding. It contraction is happening, and contraction is happening to the origin point. That much it is shrinking to the origin point. Now calculate the flux density. This is what is the flux density. Calculate the flux of a sphere, divide it by the volume of the sphere, where volume tends to 0. We are trying to calculate the nature of the energy source, nature of the energy source, power of the energy source that is kept at the center. If we want to calculate the power of the energy source, then through that energy source, take a sphere, calculate the how much flux it is generating on the surface of the sphere, divide it by the volume of the sphere, it will give the power of the energy source kept at the center. If someone wants the power of the energy source kept at any point, then around that point, make a 3D shape, either a cube or a sphere or something like that. Calculate the flux, divide it by the volume. Try to make it volume tends to 0. Then at that point, the nature of the energy which is emanating the liquid, how much is the power of the liquid, that will be known by the flux density. Or there is something called divergence. Divergence means consider this is centered at the origin. This is centered at the origin. Now, if it is centered at the origin, from this side liquid is entering and this side liquid is exiting. Liquid is seeing same surface outside when outgoing, same surface incoming. Now, in that sense, if liquid that is coming out is of more velocity, then inside it at some point, there is energy source which is increasing the velocity. Since it is centered at the origin, if I contract it, if I do contraction of this, if I make it smaller, then this very small sphere will be centered at the origin only. Now, in that sense, that if I take that sphere that is very small, then at the origin, there is energy source, whatever it is. Okay, that is understandable now. Whatever it is. Now, if there is a liquid that is entering here, and liquid coming out here, if they are of same speed, then liquid is Fi. The liquid, the liquid velocity is the nomenclature is given as Fi, capital Fi, because it is only in x-axis, Fi. Now, if the liquid that is entering here, liquid that is entering here, and liquid that is coming out from here, it has same velocity, then F is the velocity of the liquid. Then F is not changing if it is moving along the x-axis. If it is not changing, then flux is zero. Because the way it is entering here, then velocity into surface area, same way it is exiting here, velocity into surface area, and net flux is zero. But if it net flux is not zero, means velocity is changing. Here velocity is entering at one velocity and velocity is exiting at another velocity. If that is the case, then there is a flux. There is a flux. If there is a flux, means at the center of it there is another energy source is there where it is diverging. Diverging means it is throwing liquid all around. And because of that, liquid is getting added and liquid velocity is growing and more velocity is coming out of it. But in layman's term, if you ask layman term, the velocity here, the net flux is velocity into area. Net flux is velocity into area. This side velocity into area is negative because area vector is along negative x side. This side velocity vector is positive and net addition is positive, means velocity vector is changing. There is an energy source or not, I don't know. But velocity vector, when it is passing this 3D shape, inside that on the x-axis, slowly it is changing. And when it is coming out, it is changed. So df1 by dx is there. If df, I'm sorry, df, if df by dx is 0, then entering velocity and exiting velocity are same because it is not changing. Differentiation means per unit change along the x-axis making how many unit of change? D anyway, d alpha by d beta. If there is one unit of change in beta brings how many unit of change in alpha? D alpha by d beta. Or a simple division alpha by beta. Differentiation is division only, right? D alpha by d beta. Per unit change in beta brings how many unit change in alpha? Okay. Similarly, if I say df1 by dx, if I move one unit along x-axis, how much f is changing? df by dx. If df by dx is there, then certainly there is some energy source kept inside and it is making divergence. It is adding energy and net energy that is coming out from here is more. If divergence is negative, then net energy coming out from here, flux, is less because that is a black hole. It is sucking the liquid. So divergence can be positive, divergence can be negative. If there is an electric field that is kept at the center, energy source, and then it is not doing anything, keeping quiet, then there is no divergence. The way liquid is entering, same way liquid is exiting, same speed. df by dx is zero. No change in f is seen if I move along x-axis. If there is a positive change, if I move along x-axis, then that point, the energy source that is kept at the origin, it is emanating. It is throwing energy. If it is decreasing, df by dx is negative, means it is decreasing. There is a black hole there that is sucking the liquid and liquid velocity is decreasing. So divergence is nothing but df by dx. If there is a velocity field and it has x component f1, y component f2 and z component f3, the f vector, velocity vector is f1i plus f2j plus f3k. Then net divergence what we see, then consider the liquid is entering here. Liquid has any direction like this, which has x component as f1, y component has f2, and z component as f3. Okay, if that is the case, then liquid is f1i plus f2j plus f3k. Net divergence is df1 by dx plus df2 by dy plus df3 by dz. This is up to here only it is mentioned in the book. What I am going to talk now is it is not mentioned in the book. What is the next divergence? I have already demonstrated this earlier. What is the next net divergence? If this is origin, and at the origin I have kept one energy source. Okay, now this velocity of a liquid is coming because of some energy source outside. Velocity is actually in this direction. Its f1 component is this, f2 component is this along y-axis, and f3 component is this. Now consider this is minus xi plus y by 2j, or minus xi plus y by 4j plus 3 by 4k. I'm sorry. Minus xi, this is the velocity field. Minus xi plus 1 by 4yj plus 3 by 4zk. This is the velocity vector. If I calculate the df1 by dx, it is minus 1. df2 by dx, it is 1 by 4. 1 by 4y, 1 by 4. df3 by dx is 3 by 4. If you settle it, it becomes 0. It becomes 0. Minus xi plus 1 by 4 yj plus 3 by 4 zk. It becomes net flux is 0 outside the full surface. How it is that minus x, if this is origin, minus xi means from this side velocity is going towards the origin, and from this side also velocity is going towards the origin, minus xi. If I take point as 10, then 10 minus I, minus 10i, minus 10, minus xi means minus 10i. Minus 10i is same as 10 minus I in minus I direction, means it is going toward the origin. If I take minus x-axis and minus 10, then minus xi means 10i. 10i means it is going toward positive x-axis. So liquid is coming from both sides toward the origin, and it has velocity of x. Okay, similarly, liquid y by 4, y by 4, and z is y by 4y and 3 by 4z, 3 by 4zk. This is z axis, this is minus z axis. If it is 3 by 4z positive, if I take positive point here, 4, 4, then it is 3k. It is going in this direction. If I take minus z axis and I take here as 4, minus 4, then it is minus 3k. Minus 3k is same as 3 minus k. It is going in this direction. So along z axis liquid is going outward. Similarly, in y axis liquid is going outward. But in x-axis, liquid is coming to the center because it is minus x. Now it is matter of concern now that whatever is liquid is coming to the center, its same amount is going in y direction and z direction. If amount is same, then there is no divergence at the center. The energy source that is kept at the center, it is not throwing, it is not gushing any liquid at all. It is just keeping silent, and it is just diverting the energy. That's it. It is minus xi plus 1 by 4 yj plus 3 by 4 zk. This explanation is not available anywhere else. Now make a pipe at the center, make a junction. Means there are 6 pipes. Okay, 2 pipes are coming from x-axis, 2 from y-axis, 2 from z-axis. They are making a junction. From x-axis, throw a liquid toward the center. That liquid will be now it will propagate in y direction and z direction. Don't put any energy source at the center. Then whatever liquid is coming, it will go in x and y and z direction equally. Net divergence at the center, because there is no extra energy that is thrown anywhere. Whatever energy is coming, same energy is distributed. There is no extra liquid that is mixed at the center, no energy that is mixed at the center. So net divergence at the center is 0. df1 by dx minus 1 df2 by dy 1 by 4 plus 3 by 4, 0. If I say minus xi plus yj plus zk, then it becomes minus 1 plus 1 plus 1. Net is 1. Means there is energy source at the center, and it is adding 1. Okay, it is adding some liquid. That's why from x-axis, if the amount is 1, then along the y-axis amount is going is 1. But along then, how much one is going in z axis. There is an energy source at the center and it is throwing in z direction. This is called divergence. Divergence means energy source is throwing energy. Divergence is positive, means it is emanating energy like sun releases energy. And if it is negative like a black hole, which absorb energy. Consider it is minus xi plus y by 3j plus y by 2, sorry, minus xi plus y by 3j plus z by 2k. Now df1 by dx minus 1 plus 1 by 3 plus 1 by 2. 1 by 3 plus 1 by 2 will be 5 by 6. 5 by 6. Where it went? The coming is minus 1, where going out is 5 by 6, less than 1. Well, there is a hole. There is a hole at the center, and because of that hole, the liquid is dripping. Okay, this is called negative divergence. Or earlier example I gave, that is for positive divergence. Anyway, now when I know the calculation or flux density, if someone wants to very curious about it, minus xi plus yj plus zk, how much is the flux, how much is the flux density, then make a cube region. So cubical region will be easy in this sense. Make a cubical region and compare the flux all the sides and then divide it by the volume of the cube, then it will come as 1 only. Minus xi plus yj plus zk df1 by dx minus 1, 1, 1, it is 1. Same, like let's calculate. Let's take a cube where the length, breadth and height is 1. If I take this side, then velocity is minus x, and this side the area is y and z. I have taken 1. 1 is the length with height, and y into z is 1. 1 into minus x. Minus x, since this is origin, and at the origin cube is kept, this is minus 1 by 2, this is 1 by 2. So here at minus 1 by 2, okay, what is the flux? Flux is minus x into the surface area, okay, into the surface area vector. Surface vector area vector is along the minus I direction. So minus xi dot product with y into z, that is the area, minus I gone. Okay, now it is x into y into z. X is minus 1 by 2, y into z is 1, minus 1 by 2 is at this side. Okay, if that is the case, then this side it will be 1 by 2. Now in this side it will be again the minus xi, because velocity vector is minus xi, multiplied by y into z, that is 1 into 1 in I direction, minus xi dot y into zi, it becomes minus xi, become minus x into y into z. Y into z is 1, because that is the surface area, minus xi, half. So minus half only. This side also minus half. This side also minus half. Net flux coming on this side plus this side is minus 1. Similarly, if someone calculates this side where it is yz, then it will be 1. This will be 1. If you add the net flux in this, then it is minus 1 plus 1 plus 1, 1. 1 divided by 1 cube, that is the side, then it will be 1 only. So flux density, that is the net flux divided by the volume, is same as df1 by dx plus df2 by dy plus df3 by dz. One small example we will take. We had taken an electric charge. If someone remembers, consider there is an electric charge. Consider there is an electric charge. It is kept at this sphere at the center. At the center of the sphere, there is electric charge kept here at the center. Center of this sphere is centered at the origin. The origin is at the center. That is case, this is x-axis, this is y-axis, this is z-axis. At the center, electric charge is kept. Now, what is the formula of electric charge? Q into R vector divided by R to the power 3. That is the electromagnetic liquid. It is gushing out from the electric charge. Electric charge r vector divided by r to the power 3 or electric charge by r square into r unit vector, only unit vector. Now let's go with the Cartesian coordinate system. Then q into xi plus yj plus zk divided by r to the power 3, x square plus y square plus z square to the power 3 by 2. Now let's calculate df1 by dx, df2 by dy, df3 by dz, df1 by dx. Someone calculate f1 is xi by x, f1 is x by x square plus y square plus z square to the power 3 by 2. df1 by dx. First we differentiate numerator, then it becomes 1 by r to the power 3, x square plus y square plus z square to the power 3 by 2, plus now I will differentiate the denominator keeping the numerator as per the multiplication rule in kind of differentiation. Then x into by 3 by 2, it will go up as minus 3 by 2. Then it will become x into minus 3x minus 3x square divided by x square plus y square plus z square to the power 5 by 2. If someone settle it down, okay, just leave it. Now it is 1 by x square plus y square plus z square to the power 3 by 2 minus minus 3x square divided by x square plus y square plus z square to the power 5 by 2. Similarly, df2 by dy, df3 by dz. If someone add everything, then it becomes 3 by x square plus y square plus z square to the power 3 by 2 minus minus 3x square plus 3y square plus 3z square divided by x square plus y square plus z square to the power 5 by 2. If someone divides it, then it becomes 3 by x square plus y square plus z square to the power 3 by 2. Net is 3 by x square plus y square plus z square to the power 3 by 2 minus 3 by x square plus y square plus z square to the power 3 by 2. 0. It does not have flux density at all. If there is an electric charge that is kept at anywhere and charge is q, the electric field that is coming out from here is q r vector divided by r to the power 3. The net flux density at that point, I'm not talking about flux density at that point is 0. df1 by dx plus df2 by dy plus df3 by dz. I believe this is a good candidate now to analyze it, that how it is 0. So it is disproved that if I keep a sphere around the surface, around the point, if I keep a sphere around the point, then net flux that will come out of the sphere is 0. Then only divide by the volume will be 0, that is the flux density. But net flux coming out, which has radius r, coming out from the charge is 4 pi. We have measured it, 4 pi. Flux density is 4 pi q. Q 4 pi divided by 4 by 3 pi r q. Pi gone, 4 gone. The net flux density is 3q divided by r to the power 3. But here flux density is giving 0. Okay, df1 by dx plus df2 by dy plus df3 by dz. If this is the equation of flux density or divergence, then it is 0. Whereas if the flux density or divergence, another fundamental is calculate the net flux divided by the volume, then it is coming as 3q divided by r to the power 3. How it is possible? Flux is there, flux density is there, divergence formula is correct. Then why divergence is coming as 0? Then is it really 0 or non-zero? Certainly it is non-zero. Then how it is happening like this? So this can be one assignment and people can calculate. Focus on the, we are calculating the divergence at origin because charge is kept at the origin, and formula is q r vector divided by r to the power 3, q xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. This is the liquid velocity. Okay, net, if this is the liquid velocity, the net flux density at the end we calculated as q into 4 pi divided by r to the power 3. Again, r to the power 3, that is x squared plus y squared plus z squared to the power 3 by 2. Okay, flux density, leave the flux density. If I see the vector field, that is velocity, then calculate the velocity at the origin. Check it is defined or not. Okay, if you see, if it is not defined, velocity is not defined, then divergence formula will not work because it has to be defined. We will talk about it and we will take some real life example, that how we will proceed. Don't mind supporting us. Plus 91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the India country.